All right, let's get into it. Today, we're pulling back the curtain on the invisible magic that basically runs our entire digital lives. We're talking about network switching, the absolute genius system that lets billions and billions of devices talk to each other like it's nothing.
I mean, really think about that for a second. You hit send on an email, and boom, it shows up on a screen on the other side of the planet. How in the world does that little piece of data navigate the insane, tangled web of the internet to find that one specific person out of billions? Well, that's exactly the mystery we're solving today.
So to really appreciate just how clever the solution is, we first have to wrap our heads around the problem. And trust me, the scale of this problem is, well, it's almost impossible to imagine.
Just try to picture it, running a separate physical wire from your computer to every single other computer, every server, every smartphone on Earth. It would be a total logistical nightmare. The number of cables would be mind-bogglingly huge, completely unmanageable. It just couldn't work. We had to find a smarter way.
And that smarter way? It's called switching. This is the brilliant, elegant answer to that impossible web of wires. It's the whole technique that lets our devices connect to each other logically, without needing a direct line between every single one.
So what is it really? At its heart, switching is all about forwarding data, intelligently. Instead of just shouting information out into a crowded room and hoping the right person hears it, a switch is more like leaning in and whispering the message directly to the one person it's for.
Let's bring this down to a smaller scale. You know, in your house or your office, you've probably got a network switch, even if you don't know it. It's that little box that connects your laptop, your phone, the printer, maybe your smart TV. It's basically a local traffic cop, making sure that when you send a file to the printer, it only goes to the printer, and not, to your PlayStation.
Okay, now this is the really cool part, how the switch actually does its job. It's like a 5-step dance. First, it gets a little chunk of data, which we call a frame. Then it peeks inside that frame and pulls out a unique hardware ID. Think of it like a permanent serial number for that device, called a MAC address. The switch looks up that address in its own little internal phone book to see which physical port the destination device is plugged into. And then, this is the key, it sends the data only to that specific port. And for the final trick, it makes a note of who sent the data, constantly updating its own map of the network so it gets faster and smarter over time.
Right, but as networks got bigger and bigger, a huge debate started. See, it turns out there isn't just one way to do all this. Two completely different philosophies, two totally different ways of thinking about how to move data basically came to define the entire digital age.
Now, you can see there are a few different ways to do this switching thing. But the real story, the heavyweight championship fight that shaped the world we live in today, was between circuit switching and packet switching. So that's where we're going to focus.
And to make this really, really clear, we're going to use a dead simple analogy. Just think of it as the difference between reserving your own private road versus just using the regular old postal system. This quote absolutely nails the first method, circuit switching. So imagine you need to send a bunch of cars from one city to another. With circuit switching, it's like you call ahead and have the entire highway, every single lane, reserved just for you for the whole trip. And this shows you exactly what that looks like. Before any data even starts moving, a dedicated end-to-end path is created and locked down. This is exactly how old-school telephone calls worked. You'd pick up the phone, a connection was made, and that physical line was yours and only yours until you hung up. The quality was perfect, but here's the catch. If you weren't talking, that entire resource was just sitting there, completely wasted.
Now for the other way of thinking, which is much more like our postal system. This is packet switching. So instead of sending one giant message down a private road, you break your message up into 1,000 little postcards, or packets. You just dump them all into the mail. Each postcard has the final address on it, but they don't have to stick together. One might take a route through Denver, another might go through Atlanta. They each find their own best way through the system depending on traffic, and then they all get put back together in the right order at the other end.
So let's put these two head to head. The private road, circuit switching, gives you that dedicated, reserved path. It's perfect for a continuous stream of data, like a phone call. On the other hand, the postal system, packet switching, has no dedicated path at all. All the resources are shared by everyone, and your data flows in little independent packets. The big takeaway here is that one is built for guaranteed quality, while the other is all about flexibility and efficiency.
So, which one won? Well, if you're watching this right now, you already know the answer. The entire internet, everything you do online, is built on one of these ideas. Let's dig into why the internet chose packets.
The absolute bedrock of the Internet, the Internet Protocol, or IP, is a type of packet switching called datagram packet switching. All that really means is it's the purest version of that postal system idea. Every single packet is its own completely independent traveler, a datagram, that has all the information it needs to find its own way home.
And the advantages for building a global network were just massive. It's incredibly flexible and tough. If one connection somewhere in the network goes down, it's no big deal. The packets just find a different way around the problem. It's also insanely efficient. The network lines are shared, so bandwidth is only being used when data is actually moving. And all of that adds up to massive scalability, which is what allowed the Internet to grow from a tiny experiment into the global force it is today. But, and you knew there was a but coming, right? There's a price for all that flexibility. Since all those packets can take different routes and get stuck in different traffic jams, their arrival time is unpredictable. This creates something called jitter, and it is the literal reason why your video call sometimes stutters or freezes up. Sometimes packets can even get lost completely and have to be sent all over again. The bottom line is, with packet switching, there is no quality guarantee.
And that really brings us to the final thought here. The people who designed the Internet made a very deliberate choice. They decided it was more important to build a network that could survive damage and grow to an unimaginable size than it was to build one that was perfect in real time. They chose resilience over perfection. So the next time your video call glitches, just remember that trade-off. Is a little bit of lag a fair price to pay for a system that connects pretty much all of us all across the globe?